Okay, Chapter 6 deals with higher degree polynomial functions. So, now we're going to deal with polynomial functions that are, and what I mean by higher degree, they are cubic, quartic, and we're going to look at graphs of higher degree polynomial functions. Things with a cube in it, things with a quartic, maybe to the fifth power, etc. And we're going to identify, find minimums and maximums. This is a big preview for you guys for applied calculus. So this is a lot of the things that we're going to be looking at. So let's start talking about a cubic function. Now a cubic function has some kind of x cubed in it. Now, if all the rest of these things are 0, we know what this looks like. It does this. But the rest of these guys have to be 0. Or, well, at least B and C do. D, of course, if it's not 0, we know this moves up and down. So, if we have a situation, and then, of course, if A is 0, then this is a quadratic, because that one's not there. So, but if it has something, it has an x squared term and an x term, it usually has a different shape unless it can be written, of course, something like x minus h cubed plus k. And in that case, we can actually just graph it like this. However, most cubic functions cannot be graphed like that. And we have to look at their end behavior. So the first thing we do is, what does a cubic function's end behavior do? Well, it's one end up, one end down. That's what the end behavior of a cubic function. One side goes up, one side goes down. So when I'm talking about end behavior, I mean really big x or really small or really negative x. So what are these things doing when we go to infinity or negative infinity? And what's happening is, if the leading coefficient is positive, it opens up on the right. So that means that it looks like this, like x cubed, or it can look like this. So this is going up on the right side. So you'll notice the function is increasing at the end. Increasing at the end. So that is if the leading coefficient is positive. A is positive. But when A is negative, we're going down on the right side, so it might look like this, like negative x cubed, or we might have some other things that happen in there. This is when A is negative. So, and in general, the graph of a polynomial function of degree n has at most n x-intercepts. So how many x-intercepts do you suppose this could have? Let's look at this. So what if this thing was here? Then this would be one x-intercept. What if it's something like in this location? Then it's 3 x-intercepts. Because it crossed. But can it be 0? Does this have to go through the x-intercept at least once? I want you to think about that. And the answer is yes, it does. So in this case, it's either 1 or 3. Most of the time. I've just thought of one that is actually exactly 1, and that is, or exactly 2. And that is if, well, or 2, I should say, 2 x-intercepts works, and I'm going to show you how. if it's here and here. So if it goes right there and then on the turnaround point of that, that's 2 intercepts. So it has to have at least 1. It has 1, 2, or 3. So at most, n though, the most it's ever going to have is 3. So if we find 3, we know for sure we have them all. If we find 1 or 2, we just have to investigate the graph to see where the graph is. So let's look at this. Now a cubic function will have 0 turning points or 2 turning points. If it can be written in the form y equals ax minus h cubed plus k, then it has 0. If it cannot, then it has 2. So, and of course the first one looking something like that, and the second one has to turn like this. So these are the 2 types of graphs we're going to have. These turning points, so if we do have these turning points, these are called local extrema. So what I mean by that is, that means this is local max. This is a local minimum. So if this local max means it's higher than what's around it. So I can take some kind of interval right here, and then this is the max of that interval. That makes it a local max. And then this one is lower than what's around it if it's a local min. So, and this is also the point where the curve changes from decreasing to increasing. So it goes from decreasing, so this is decreasing, and now we're increasing. And then we're at increasing, and now we're decreasing, is a maximum point. So we can also think about it that way. Now the lowest point on a graph over an interval is the absolute minimum and absolute maximum. So if I have, let's say I have a graph, and it looks like this. Let's say this stops right here. So we have a certain interval where we're going. So maybe this is x equals 0 to x equals 10 or something like that. Now in this case, my locals are my absolutes. However, let's say for the sake of the argument that I wanted to cut it off here. Then the maximum would actually be this point instead of this point, because it depends on where I'm going to cut off the graph of this function. So let's look at these cubic functions and let's think about these for a minute. So looking at this first one, this has one x-intercept. Okay, it has 0 turning points. And it can probably be written y equals x minus h cubed, a times x minus h cubed plus k. Now let's look at this one. And also a, since we're going up, our n behaviors goes up, and the right side, a is positive. Now looking at this one, again, n behavior, a is positive. Can this one be written in this format? The answer is no. We have 3 x-intercepts, 2 turning points, and our a is positive. It cannot be written in that form. Okay, let's look at the next one. Now this one, let's look at the n behavior. Let's look over here. Our n behavior is, as x is going to get bigger, this is going to go really, really small. So that means a is negative a little bigger for you guys. A is negative. And we have, how many times do we cross the x-axis? Well, 1, 2, 3. So we have 3 x-intercepts. And we have 2 turning points. And so again, this one cannot be written in this format. Okay, so let's look at a cubic graph. So we need to use an appropriate viewing window so we can find the local max and the local min. And then we're going to talk what's the absolute minimum of this function on the interval 0 to 3. So we want x cubed minus 8x. So let's look at our calculator. And let's go x, and then cube, you can actually hit math3 to bring up a cube automatically, or you can use caret 3, it doesn't matter. But then you have to move over 1, minus 8x. So x cubed minus 8x. So all I'm going to do right now is I'm just going to zoom this to 6. And let's just look at it. Okay, is that an appropriate viewing window? And the answer is yes, it is. I just use the standard negative 10 to 10, negative 10 to 10. So, and I can see the intercepts and the turning points. So I can see what I need to see. So it is an appropriate viewing window. So part B, find the local max and local min if it's possible. So it is. So our local maximum is right here. Our local minimum is right here. So we can use our calculator in order to find these. So remember, we're going to go second trace, not just trace. We go second trace to bring up calc. And I want to go to maximum number 4. So left bound, I need to go to the left side of this. So I'm on the left side of where I see the minimum. I hit enter. Now I want to go to the right side. Enter. And see these answers down here. This is just where I'm at right now. I want to give it a guess first. I have to go through every one of these steps. And then my real maximum is at x equals negative 1.633 and y is 8.709. So this is the local max. And then let's try my local minimum. So I go second, and you wait till this says maximum. You have to wait till that says maximum when you're looking at this. Now we go second trace again. Now we want minimum number 3. And now we have to go way over here. So I'm going to be just on the left of it. Now I make sure I'm past it. I am. And my guess is I put it near it and I do a guess. See, it says guess. Anytime it's got a question mark, it wants you to do something. So the minimum, so my local minimum is at 1.633 and y equals 8.709. So it's actually just the opposite. Oh, negative. Can't see that very well right there, but it does say negative, and it looks like it's negative also. Okay, so now it's asking us a different question. Now, where's the absolute maximum of this function on the interval 0 to 3? So I'm actually going to go to my window, and I'm going to change this 0 to 3 so that I can see what this looks like from 0 to 3. Now, it looks like my maximum is at the very end right here. So I'm going to find out what that point is right there at 3. Because I'm thinking this is 0 right here. So it goes 0. And at 3, it's a little bit higher than that. So that looks like the highest point I'm at. So all I'm going to do is I'm just going to tell it, give me the value x equals 3, and it says that y equals 3. So it's at x equals 3, y equals 3. That's the maximum of the function on this interval. So I'm only looking at this piece of the function. So the end point of one of this interval is where the actual maximum is in this case. The minimum is still the same. The minimum is still this guy right here. But the maximum, because we're limiting ourselves only for 0 to 3, it's at x equals 3 and y equals 3.